This is another video that will discuss more problems with operations with radicals and complex numbers. If you take this first problem, and we've got square root of 6 times the square root of 9. There's no factor out here besides 1, but out here we've got -1. So what we're going to have is -1 times square root of 6 times the square root of 9. We could say is the square root of 54. And then we could simplify that, but we see that what we're going to get back to is where we started. So square root of 9 becomes 3 times square root of 6. So really, to begin that, we could have started with just taking the square root of 9, and since it is a -1 times the square root of 9, we could go ahead and simplify that to -3, and then the square root of 6 would remain. Second problem is using distributive property. So the -4 times the square root of 5 times 4 would be -16 square roots of 5 minus, and then we look at -4 and -3, so that would be a +12 times the square root of 50. And we always want to think, how can I simplify? Square root of 5, the 5 radicand is prime, so I can't find another factor, so that will stay the same. And then square root of 50 would be 25 times the square root of 2, and don't forget the 12. So I have -16 square roots of 5 plus 12, and then the square root of 5 becomes 5 times the square root of 2. So I get -16 square roots of 5 plus 60 square roots of 2. I am finished. I simplified because I cannot add square roots of 5 and square roots of 2. So when you're multiplying, you can multiply the radicands and then look to simplify. Part C is another example of a distributive property. So 3 square roots of 6 times 10 would be 3 square roots of 60 plus 3 square roots of 18 times 6 would be 108, and 60, and 60 divided by 4, yeah, so we actually have 4. So square root of 15, square root of 4 times 3. And square root of 4 becomes 2. So 3 square roots of times 2 square roots of 15. So that'd be 6 square roots of 15. So 3 square roots of 60 simplified to be 6 square roots of 15. Plus 3 times, and the 108 would be the square root of 36 times 3. Square root of 36 becomes 6. So this will be 18 square roots of 3, and I'm finished. And I know that because the radicands are different. So I cannot add those together. Part D, I'm going to distribute again. So I get -4, since there's a 1 out here, so 1 times -4 is -4. Square root of 5 times square root of 8 would be square root of 40, plus 1 square roots of 5 times 2 square roots of 10 would be 2 square roots of 50, excuse me. And then I look to simplify both the square root of 40 as square root of 4, square root of 10 times -4. So I'm just bringing the -4 factor down. Again, I'll do that. So that square root of 4 would be 2 square roots of 10. So -8 square roots of 10. Plus 2, and then 50 would be square root of 25 and the square root of 2. So that would be 2 times Square root of 25 becomes 5. Bring the 2 down. Bring the square root of 2 down. So this will be 2 times 5 is 10 square roots of 2. And I cannot simplify because square root of 10 will not factor anymore. There's not a perfect square factor of the square root of 10. And finally, part E, notice it has 4 terms. So we're going to use the distributive property 4 times, twice. Square root of 8 will be multiplied to both terms. So square root of 8 times the square root of 3 would be the square root of 24. Square root of 8 times negative 3 square roots of 20 would be negative 3 square roots of 160. And then we'll take this term and multiply it by both terms. So this would be 2 square roots of 30. And then here we've got 2 times negative 3, so negative 6 square roots of 200. So I do have 4 terms. And we go through our process and we simplify as much as we can. So looking for perfect square factors, square root of 4, square root of 6, so that'd be 2 square roots of 6. Minus 3 times, this would be 16, square root of 16 times 10. So negative 3 times 4 times the square root of 10. Square root of 30 will not simplify anymore because there's no factors that are perfect squares. And then anytime you see a 100, 200, 300, 500, 700, any of those numbers, then you know that 100 is a factor and it's a perfect square. So negative 6 times 10, because square root of 100 becomes 10. Bring down your negative 6. Multiply by the square root of 2. So just kind of clean this up a little bit. I've got 2 square roots of 6 minus 12 square roots of 10 plus 2 square roots of 30 minus 60 square roots of 2. I'm looking at square root of 2, square root of 30, square root of 10, square root of 6. Nothing is alike, so I'm finished. So just a couple more to look at. This would be the 3 square roots of 6 times 10 would be 3 square roots of 60. 3 square roots of 6 times negative square root of 3 would be negative 3 square roots of 18. And then factors, so 3 square root of 4, square root of 15, minus 3, square roots of 9, square roots of 2. Square root of 4 is 2. Square root of 9 is 3. So I'm going to get 6 square roots of 15 minus 9 square roots of 2. So again, you're looking to your process is distribute to both terms. Square root of 6, square root of 10, you can multiply the radicands and then look to simplify as much as you can. So we'll look at part G. Square root of 6 times the square root of 2 would give us the square root of 12 plus the square root of 18. And just previously, we know the square root of 18 would be the square root of 9, square root of 2. And then the square root of 4 and square root of 3. So this will be 2 square roots of 3 plus 3 square roots of 2. Square root of 9, square root of 2. And 3 square roots of 2. And that would be your final. When we talk about conjugates, just kind of switching gears, because we're going to look at what happens when we're multiplying. When you multiply conjugates, what you see that happen is here, this is a result of your difference of squares. Notice that when you multiply those out, you'll get x squared minus 3x plus 3x and minus 9. So we lose the two middle terms. So conjugate pairs, when you multiply them out, will actually lose the two middle terms. Well, think about when you're, let's go back to what we said, I was equal to the square root of -1. Well, if I want I squared, well, this is the second root, so this is -1 to the 1/2 power. If I want I squared and I square both sides, then I'm going to get I squared to equal -1. So anytime I'm working with multiplying and complex numbers and I see an I squared, I know that I can substitute it with -1. Now, the conjugate that I mentioned will be used here on C because this is an A plus B format. So we will use conjugates when we are rationalizing. And here we're looking at division of radicals. So it's not simplified form if you have a radical in the denominator. So what we can do in part A is we can look to factor square root of 15, and we look to factor square root of 12. There's a couple of ways to do this. This one way is to kind of break up the factors. You see square root of 3 divided by square root of 3, so we can divide out. And then you see square root of 5 divided by square root of 4, which the square root of 4 would be 2. I do not have a radical in the denominator, so I'm finished here. Now, another method would be if you wanted to rationalize it, just means we would multiply the numerator and the denominator by the square root of 12. Well, what you would get in the denominator is the square root of 12 times the square root of 12, which would be the square root of 144, which is 12. Square root of 15 times the square root of 12 would be the square root of 180. And here, for thinking perfect squares, we could say the square root of 36 and the square root of 5. And the square root of 36 is 6, so just continue down here. The square root of 36 is 6 times the square root of 5 divided by 12. And now you're thinking, can I simplify 6/12? And you can. It would be the square root of 5 divided by 2. And that's what we found originally when we wrote them out as factors and divided out and then changed the square root of 4. So notice what we found here and what we found here. So same answer. It's your choice on whether you want to rationalize it. Sometimes you don't have a choice. You just have to rationalize it anyway, even though you could possibly break it up into factors. So we'll look at another example. Square root of 4 and 2 square roots of 20. Well, we could just say, well, let's leave square root of 4 and let's factor the square root of 20 to the square root of 4 times the square root of 5. And notice these will divide, so you're left with 1 divided by 2 square roots of 5. Well, I still need to rationalize it because I have a radical in denominator. So I would multiply both numerator and denominator. That's the rationalizing piece. Multiply both numerator and denominator by the radicand, the radical. So you have square root of 5 here, so it'll be square root of 5 in the numerator, square root of 5 in the denominator. So 1 times square root of 5 is square root of 5. What's the square root of 5 times the square root of 5? Well, that's the square root of 25, or 5 and 5 times 2 is 10. Let's look at part C. Since I have two terms in the denominator, I'm going to multiply by the conjugate, which would be square root of 2 plus the so square root of 2 plus 5 square roots of 3, and square root of 2 plus 5 square roots of 3. And so notice, what's the conjugate of the denominator here? Well, this one's square root of 2 minus 5 square roots of 3. Well, what are we going to multiply by? The conjugate. So you should see addition in the numerator and denominator, because what you're doing here is this is, even though it's a irrational form, square root of 2 divided by 5 square roots of 3, square root of 2 plus 5 square roots of 3 divided by square root of 2 plus 5 square roots of 3 is really 1. So you're really multiplying 1 by this, which doesn't change the problem because you're using the identity property. But then when you multiply 4 by both of those, you're going to get 4 square roots of 2 plus 20 square roots of 3, and then we look at what can we simplify in the denominator. So what's the square root of 2 times the square root of 2? Well, that's square root of 4, or 2. Square root of 2 times 5 square roots of 3 would be 5 square roots of 6. And then what's negative 5 square roots of 3 times 2? You get negative 5 square roots of 6. And there you go. You can already see that the middle terms are going to disappear. And then what's negative 5 square roots of 3 times 5 square roots of 3 would be negative 25 square roots of 9. And the square root of 9 is 3. So just coming down here, I would have 4 square roots of 2 plus 20 square roots of 3, all divided by, notice these two terms divide or cancel out. So I'm going to be left with 2 minus 25 times 3, which is 75. Square root of 9 becomes 3. 3 times 25, 75. So it would be 2 minus 75. So that would be 4 square roots of 2 plus 20 square roots of 3, all divided by negative 73. And then you always think if I could simplify, because really what you have here is 4 square roots of 2 divided by negative 73 plus 20 square roots of 3 divided by negative 73. Notice I left this negative in the denominator. You could always bring the negative to the numerator and make the denominator 73. And you could change it to a subtraction and say 20 square roots of 3 divided by 73. Or you could write it as negative 4 square roots of 2 minus 20 square roots of 3, all divided by 73. 73 is an odd number, so it's not going to be divisible by 2. It's not going to be divisible by 4. And it's not divisible by 10 or 5. So we're going to leave it as it is. Other examples of rationalizing. Again, like I said, you could take square root of 6 and factor it into square root of 2, square root of 3. And then square root of 27, we could say square root of 9 times square root of 3. So what happens here is those divide out, and you're left with square root of 2 divided by, and the square root of 3 is 3. And so there's your result. Or if you wanted to multiply 27, square root of 6, square root of 27, you could multiply by the square root of 27 in the numerator, square root of 27 in the denominator, and that would give you square root of 27 times square root of 27 is just 27. And then this would be square root of 27 times square root of 6 would be 162. So you have a square root of 162 divided by 27. Well, the square root of 162 would be the square root of 81 times the square root of 2, all divided by 27. And the square root of 81 is 9. So 9 square roots of 2 divided by 27. And what you're trying to do is just figure out how to simplify 9/27. So 9/27 will simplify to 1/3. So you get square root of 2 divided by square root of 3, which is what we found when we just broke it up into 2 factors and then divided out and simplified square root of 9. Either way is fine. You're going to get the same answer regardless. Square root of 15. So square root of 15, I'll say square root of 5, square root of 3. And then square root of 20, we'll say square root of 5, square root of 4. So that'll be, notice the square root of 5s will divide out. What does square root of 4 become? Well, it's going to become 2. Square root of 3 in the numerator, so you're going to have square root of 3 divided by 10. That's probably your most efficient way to rationalize it is, well, to simplify it, is that you could look for the factors. And anytime you're left with a perfect square factor in the denominator, then perfect, because then you won't have to do any rationalizing after that. Now let's take C. Let's look at part C, and that's square root of 4 divided by 4 square roots of 5. Well, the square root of 4 is 2 divided by 4 square roots of 5. And you could go ahead and simplify it 2/4 if you want to and make that 1 divided by the square root of 5. Well, we still need to rationalize it. Cannot have a radical in the denominator. So we're going to multiply. So we're going to get square root of 5 divided by square root of 5 times square root of 5 is the square root of 25, or 5. Now, if you wanted to rationalize it and not simplify, and you wanted to start out multiplying by the square root of 5 and the square root of 5, well, that would give you square root of 20. And this would give you 4. Square root of 5 is just 5. So we would have square root of 20 divided by 20. And the square root of 20 would be the square root of 4 times the square root of 5 divided by 20. And then we know that the square root of 4 is 2. So 2 square roots of 5 divided by 20. And so just making sure that looking at this top one, the square root of 4 divided 4 square roots of 5. So I just multiplied by the radicand, square root of 5, gives me square root of 20. And I know what I did. I'm looking up at C here. 2/4 simplified to 1/2. And so that's my mistake. I left out the 2 here, which would be 2 times 5 here, which would be square root of 5 divided by 10. So my mistake there. And that's what I simplified to be 4 square roots of 5. So that part right there, I knew to simplify to 1/2, and I just forgot to write the 2 down below. And square root of 5 times square root of 5 is 5, and 5 times 2 is 10. So I noticed something was off because I had 5 down there, and then I'm looking at 20 in the denominator, and I'm knowing that 2 will divide 20 10 times, so I should be left with square root of 5 divided by 10. So my mistake for overlooking that, but we caught it. And I'll just rewrite that. And so you see, get the same answer both ways. So let's look at what happens when you have an I in the denominator and you want to try to eliminate the I in the denominator. It's the same idea. You don't want a radical in the denominator. So you would do the same thing. So on part A, I've got 10 minus 10I divided by negative 5I. Well, I'm just going to multiply by I to both of these. So I'm going to get 10I minus 10I squared divided by negative 5I squared. And so remember a few slides ago we said that I squared would equal negative 1. So I've got 10I, and then this is I squared would be negative 1, so you'd see that when you substitute negative 1 in wherever you see an I squared, you would have 10I plus 10 divided by 5. And then you want to try to simplify this because both of these numerators share the denominator of 5. So you would have 10I divided by 5 plus 10 fifths. So that would be 2I plus 2, or 2 plus 2I. And that's our standard form when we write our complex numbers. Remember, we write it as A plus BI in that format. So let's look at a second one. So part B definitely have two terms. So we're definitely using our conjugate in this problem. So negative 2 minus 6I. So we're going to multiply by the conjugate, which would be negative 2 plus 6I. Negative 2 plus 6I. Why did we use addition? Is because this was subtraction. So you should look at the denominators and see that they have the same terms except one's positive and one's negative. So just go forth and start multiplying. So that'll give you negative 10I plus 30I squared, all divided by. Well, remember when you're multiplying the conjugate, you're going to multiply first terms, you get 4, negative 2 times negative 2. You know the other two terms are going to cancel out, so it's the last two and the first two that really matter. So negative 6I and a negative 6I would be negative 36I squared. And then what do we notice is going to happen here? Well, I squared would be negative 1. So we would get negative 10I plus 30 times negative 1, and then 4 plus 36. I jumped ahead there, but this is what you're going to see is 4 minus 36 times negative 1, and negative make a positive. So you're left with negative 10I minus 30 and 4 plus 36. So we get negative 10I minus 30, all divided by 40. And then they both share the denominator of 40. So we're going to separate and try to simplify as much as we can. So 10/40 would be negative I divided by 4 minus negative 3 divided by 4, or negative 3 minus I, all divided by 4. Let's look at part C, again with the conjugate. Negative 4 plus 10I divided by 3 plus 4I. So the conjugate, if the denominator is 3 plus 4I, the conjugate would be 3 minus 4I. Good. All right, so again, we're going to multiply. So that'll give us negative 12 and a positive 16I and a positive 30I and then a negative 40I squared, all divided by, here's the conjugate again. So 3 times 3. Let's multiply the first terms to get 9. And let's multiply the last terms to get negative 16i squared. And what are we going to see happen again? We're going to get a positive value. Because when you're multiplying the two last terms in a conjugate, you're going to get negative something. Well, I squared is negative 1. So you're going to get negative 16 times a negative 1, or a positive 16. So you're going to get 9 plus 16 in the denominator. Let's clean this up here in the numerator. We're going to get negative 12 plus 46i. And then what happens here with I squared? That's a negative 1. So negative 1 times negative 40, you get a positive 40. So now I can combine these two. So negative 12 plus 40, so that's going to give me 28. And plus 46i, all divided by 25. And 25, the only factors are 5 and 25 and 1. So 5 will not divide any of those. So we're finished. Okay, so part A would be 2 plus 5i divided by negative I. So I'm just going to multiply it by I. There's not really a conjugate here. I could multiply it by negative I. That would eliminate the negative in the denominator, and that's okay. So that would be negative I times 2 would be negative 2i. Negative I times positive 5 would be negative 5i squared, all divided by negative times negative is a positive I squared. But what we know is I squared is negative 1. So 2i minus 5 times negative 1, all divided by negative 1. So 2i plus 5 divided by negative 1 is just going to change the sign. So I'm going to get negative 2i minus 5, or we would write it as negative 5 plus a negative 2i, or negative 5 minus 2i. So let's look at part B. That'll be the last one of this set. So negative 5 minus 9i divided by 9 plus 8i. So the conjugate would be 9 minus 8i and 9 minus 8i. So we're going to go through and multiply again. Negative 45, positive 40i, minus 81i, and positive 72i squared. Again, conjugates, so multiply 9 times 9, you get 81. And then the last term would be negative 64i squared. So again, we're seeing negative times negative. We're going to get a positive in that denominator. So negative 45, and then 40 and negative 81 would be negative 41i minus 72, because this I squared is going to become negative 1, and negative 1 times positive 72 is negative 72. And then what happens here is we're going to get 81 plus 64. So I'm going to get negative 45, and I'll go ahead and simplify that. Negative 45 and negative 72 will be a negative 117. So minus 117 minus 41i, all divided by 145. And 117 is not divisible by 4, and neither is 145, so we would leave it as it is. So if you're looking at a check, if you take this problem right here, notice there's two binomials, so you would multiply distribute twice, and you're going to get an I squared pop up in your expression. So you would simplify and substitute -1 for I squared. Here is just to distribute the square root of 5 to both terms. Once you do that, you want to simplify the radicands. And then here with dividing radicals, there's lots of different ways we can multiply by the rationalizing, by multiplying by the denominator, square root of 6, or we can break down the number into its factors and try to find something that will divide out, which those do, which would leave you square root of 5 divided by 3 square roots of 2. We're still going to have to rationalize it. So, and then here with division, you would multiply by the conjugate to get started. So that'd be -10 minus 7i, -10 minus 7i. Go through your distributing. You would have to replace I squared with -1 in the numerator and the denominator.